Hi guys, my name is Vitaliy, and today I want to share with you experience we got during the development of our brand new solution for Selenium testing. And I want to talk about our past in terms of infrastructure firstly. We have a lot of experience with Selenium Grid, and this experience was not good. That's why we talk now about some sort of replacement. Selenium Grid has important downsides. First, it is a really unstable solution. We had a lot of problems regarding to stability and reliability, and we had these issues because Selenium Grid is stateful solution. There is no separation between compute and storage and so on, and also it requires a lot of huge pool of free resources to work fast and smooth. And the last, eventually it creates a broad range of Selenium configurations, I mean browsers, nodes, and so on. That's why we started to look around and think about how we can fix all this, how we can fix all these issues without huge efforts from the operations teams. After some focused thinking and brainstorms, we defined some key requirements. We don't want to manage data and think about storage, so we want our application to be stateless. Also, our solution should be lightweight because we want to optimize our resource usage, our resource consumption. Also, we thought containers and containers orchestration are really great approach to deliver software. So we want our solution to be Kubernetes-native. Because we want to increase visibility or observability, we want to use fresh and clean environment for every test running. It should help us to avoid some sort of issues, and also it should help to make all issues clearly reproducible. Now I want to talk more deeply about why we decided to use Kubernetes as a platform for our application. As you all know, Kubernetes is an open source solution, so we can get some help, some support from the community, and that's great. Also, Kubernetes brings to us a scalable or on-demand approach out of the box. And also it has powerful API. So if we want to integrate our existing solutions, we can do it easily. Finally, we can describe all our solution configuration, all our objects as code, and we can pass it through our continuous integration or continuous delivery pipelines. And that's great too. After we figured out what we want to achieve, we started to look around again, and we did some research of alternative ways to make it possible. There is no surprise that first we started to think about Selenium Grid refactoring, but we got very quickly that Selenium Grid has a huge and complex code base, and we need people with specific skills to fork it and maintain it. Also, it can be hard to integrate our changes with Selenium upstream repository. Because we already decided to use Kubernetes, we paid some attention to the Moon by Eracube. It's a nice example of Kubernetes-based Kubernetes-native application. It's easy to install and use, but we figured out some important for us, some downsides. Yes, it's really easy to install and use, but it is not possible to clearly understand how it works under the hood, because it's cloud source. Also, it is a complex solution. I want to talk about this point in details. So, when you consider to use Moon, you got one central testing endpoint for all your products, all your teams. This endpoint is dynamically configurable via some sort of Selenium settings, capabilities. And all your teams can use this endpoint. But you don't need this approach, these features, if you have only one product, or you prefer to run several endpoints, several pre-configured endpoints with various configurations. And this approach can be redundant for you. So that's exactly our case. So let's conclude our intentions. We wanted Kubernetes-native and simple solution, not less complex than Moon, for example. And lucky we had and we have a great team to get things done, to get all this stuff done. We even can summarize all our intentions in one phrase: keep it simple. I want to share with you this quote from Unix philosophy manifesto: small is beautiful, do one thing and do it well. Let's try to think about what types of application or services we usually run atop of Kubernetes cluster. How these services usually interact with Kubernetes and so on. Based on our experience, we have an opinion. Usually, ordinary, we have an external client, and this client sends some sort of request to Kubernetes cluster. It can be calls to Kubernetes API, or it can be requests to our application or service within Kubernetes cluster, inside Kubernetes cluster, in a previously created workload, for example, pod. So if we want to process request to our application, we can just use some sort of reverse proxy, for example in Nginx. But if we want to interact with Kubernetes API server, we need some service between our external clients and Kubernetes API server. So that's why we decided to create our own solution for this. And we called it Callisto. In short, Callisto is a Kubernetes-native implementation of Selenium Grid. It can create some workloads in Kubernetes cluster, for example, pods. It can return some information about workloads, about application inside these workloads, to our external clients. And also, finally, it can destroy this workload in Kubernetes cluster. Now it's time to show you how Callisto works under the hood. And also it's time to show you which types of requests flow we have in this architecture. So firstly, we need to create some workload inside the cluster. Our client sends some request to create browser to Callisto endpoint. Nginx just forwards these requests to our Callisto instance. Callisto using Kubernetes API to create a workload, and this is a pod, and in the pod we have a Selenoid container. We have a running WebDriver instance inside this container. So after the readiness of the pod, Callisto can interact with this pod, with WebDriver inside this pod, and Callisto forwards request to create browser to WebDriver, and then WebDriver create exactly the browser, So after browser creation, we just return to our client session ID of this browser. Now our browser have a session ID and can interact with our client has a session ID and can interact with the browser inside Kubernetes cluster. Client sends some testing requests to our Callisto endpoint. Nginx forwards these requests to browser, and browser makes some work, makes some tests action, and after completion of these actions, we just return to our client some sort of response. So when the job is finally done, we need to clean up the mess, and we can do it the same way as we create the browser. So our client sends requests to Callisto endpoint, we are processing it through our flow, and we are using Kubernetes API to delete our workload. And then after deletion of this workload, we just return to our client browser quit response, and that's it. That's how all this stuff works. That's all request flows we have in this architecture, and this is really simple solution. So now I want to talk with you about some high-level features of our solution, some high-level features, key features of Callisto. First, it's Kubernetes-native application. It runs inside cluster, and also it uses Kubernetes API to create or destroy workloads inside the cluster. Also, it's really stateless solution. Callisto doesn't store any session data because it uses session ID approach. Also, if you are using Callisto, you can use Selenoid images for creation of your browsers, and it's really helpful thanks to folks from IRCube. You can focus on your work, you can focus on your testing instead of browser packaging or some sort of updates, So, and the last but not less important, Callisto offers you a useful set of Prometheus metrics. You can build fancy dashboards around these metrics. in Grafana, or you can use something else. So that's how Callisto works, and now it's time to talk about notable insights we got during development, about interesting experience, about lessons we learned during the development of our solution. And first example regarding to performance. In early phases of development, we considered that we need to create a browser as fast as possible. So, but also we need effectively forward requests from clients to create our browsers. Firstly, we decided to use Kubernetes built-in features for forwarding the requests. But Kubernetes services, it's really easy to forward requests with this approach. But after some performance testing, we got this result. It's really slow process of creation of service. In our case, because we create a really huge bunch of services in short amount of time. So we need around 70 seconds to create a browser in the cluster with already running 1000 browsers or tests. And this was a really bad result. So we decided to opt out creation of Kubernetes services for our pods and started to use session ID approach. And then we got this significant increase of performance. We need less than 10 seconds to create a browser in our cluster, and that's great result, I guess. So the second example regarding to costs of our infrastructure, of our cloud infrastructure, or our service costs. It really matters for every organization, for any company. So I want to start with this one. Selenium Hub, Selenium Grid in Kubernetes is real, even on the preemptible or spot, if you prefer, AWS instances. It can save you money, but it's really unstable solution. You need huge efforts from your operations teams to make it work. So if you start to use Callisto, you can fix all these issues, because Callisto is Kubernetes-native and it's reliable and stable solution out of the box. It saves your money too, but also it can save time of your operation teams. So here you can see a notable decrease of spendings in our GCP, Google Cloud Platform project for Selenium testing in November. This is the month when we finally end our migration to Callisto. And this is really great decrease of spendings, I guess. So guys, enough talking, let's get some fun. Here comes the demo. So we have a Minikube cluster, and we will use it for deployment of the Callisto. Also, we have repository with Callisto Helm chart. First, we need to create namespace for Callisto deployment and start to use it. So now we use Helm for deployment of the Callisto. All resources were created. Now we can get some statuses of our workloads. So all our workloads are running. Now we need to add these lines to our etc host file, and it's make as possible to do some requests to our local Callisto endpoint. So we did it, and now we can use curl to make some requests to Callisto endpoint, and this is a request to create a browser. Now we need some time, Callisto needs some time to create a browser, and we should wait. Yes, great, it's ready. We have a running browser, and this is the session ID with IP address of the pod. So now we will use Selenium UI to check some things. That's really useful and great. So we have our running browser. We can use VNC here or get access to some logs. So as you can see, it's really easy to install and start to use Callisto. You can do it right now. So guys, we welcome you to contribute to our open source project. Also, we glad to answer your questions, so you can ask. Thank you and have a nice day. Good luck.